Today already we have discussed with every theory part of set theory. So today I'll be doing the exercises, very important questions, right? So in between, if you find any problem, let me know, right? So let me begin with. Okay. So I'm starting from the back side. As I told you, last day we have done 13, 14, 15, 16 questions of the miscellaneous exercise. Today we'll be doing question number 12 at the beginning, right? And I'll go backward. They are asking you to find three sets A, B, C such that A intersection B, B intersection C, and A intersection C are non-empty, whereas A intersection B intersection C is 5. So you see, this is a very easy question, right? We can do it very, very easily. Just I'll draw a figure immediately, Venn diagram, and that will lead me to find the answer very quickly, right? Three sets they are talking about. One set is this, then another set I'll draw here, right? But as you know, three sets if you draw, you keep a provision of something in common. So you draw the third set here, this is here. So now these are the three sets we have drawn. These are the three sets we have drawn. And now we are going to name the sets, right? So we have to follow the complete process. So this is the universal set. Now here this is the set A, here this is the set B, and here this is the set C, suppose. So you have to find such an example here such that this particular portion will remain empty. There will be no element belonging to this. Whereas these parts should have some elements. So that kind of sets you have to find. So it is very easy. It is very easy in fact. So how you can do, just randomly you go on putting some elements, you see the process how to draw this, how to do this, right? So first of all, I have to keep this most common part empty. So I am going to fill up elements here. Say one element one I have put here, and then two here I have put, and then one element three I have put here, then one element 4 I have put here, another element 5 I have put here, and 6 I have put here. And if you want, you can put something here outside also, but that is not needed only, right? Now you just observe. Now you just observe. What you'll observe here, you see, this particular part is empty. This particular part is empty. This is empty, right? E-M-P-T-Y. E-M-P-T-Y. This is empty. Empty indicates that intersection of A intersection B intersection C is 5, right? Whereas the other parts are not empty. Whereas these parts, these are not empty. So it is going to satisfy our required conditions. So from here you can write here, consider what will consider the set A. Now from here you read the sets A. What will be the element belonging to set A? It is 1, 2, 5. B is the set where you will be getting element 2, 3, 6, and C is the set where you will be getting element 1, 3, 4. And now clearly you can easily find that this is not equal to 5. You will be getting intersection. This is not equal to 5. You will be getting some intersection. This is also not equal to 5. But what will happen? All the three intersection will be 5. So that you try to remember. So pairwise they are not disjoint, whereas in totality, if you consider all the three sets, they are disjoint. So I have got these as the examples. So I have finished with the first question of today. So once you finish, please, the condition is that same only. Please raise the hand so that I can uh, go further once you finish it. Okay, thank you. So I'll go to the next question. Next question means it is previous next, right? That means one before that. Question number 11. This is an important question I'll be doing. Right here we are going to use one property. That property is actually is a question in question number 9. So anyway, I could have done question number 9 beforehand. Anyway, that's not an issue. I'll refer to that property and I'll tell you which property it is used. Here you have to prove that A equal to B for any two sets A and B satisfying these conditions. These means here first I am writing the conditions. A intersection X is equal to B intersection X and A union X is equal to B union X. Then with these conditions you have to prove that this A equal to B. This is the condition. This is what you have to prove. This is what you have to prove, right? So now for proving this, we'll proceed with these particular steps. We'll use the property of sets. Just you see very clearly. Set A. I'm going to use one particular result here. A union A intersection X. Just you can understand this. You can easily understand this. It's not a difficult thing to understand, right? So you just try to see whether you can understand this or not. A and then intersection of A with something. Obviously, this is smaller. Smaller than whom? A. Smaller in the sense for the notation of set, I should have said that this is a subset of A. So any smaller set, if you fuse with A, so result will be A only. So I can write this. Now once we have written it, we will divert our calculation towards B by using these given relations. That is our target. That is our target. So how do we divert this calculation towards the B? See, A intersection B can be written as A intersection X can be written as B intersection X because you have this. Next, you do the distributive property. Last day we have done this. Distributive property, if I use, I'll be getting it like this. Now, once you have finished with distributive property, wherever it is possible, apply the given condition. Here I can use A union X means B union X. It is already given, right? A union X means B union X. Very fine. So now from here you can see this B can be taken out. It is apply. We can apply the converse of distribution property, distributive property. So what we'll be getting here as I made a mistake. Sorry. This is B union A intersection X, right? Because this, if you break, I should get this. So I'll be getting it. Now B is okay. Here A intersection X can be written as this. And now again you can apply the same property what we have applied here. This is a smaller set than B. So if you take the union, you should get B. So what ultimately you arrive at A equal to B. Hence proved. There is a hint given in the book. I did not follow that hint. If you feel you can follow the hints to complete the problem. There is no problem if you do like that also. So please go through it, note it down immediately, and once you finish it, inform me, please. Okay, Swanav, thank you so much. Now, in this part only, I'll be doing one question, that is question number 10, right? 10. I'll be giving you the hints, right? I'll be giving you the hints. They are asking you to show that A intersection A intersection B equal to A intersection C need not need not imply need not imply B equal to C. Need not imply B equal to C. Meaning is what? That means sometimes you may be getting three sets A, B, and C, such that A intersection B is equal to A intersection C. But even then, these two sets are not equal. So it is a matter of providing counter examples. So this is left for you. You have to just write three sets like this, putting some elements, take lesser number of elements, and you try to say that intersections are okay. That means common elements are there, but sets B and C are not equal. That you can do just by giving a small try. You can do, I'm sure. So I'll go to the next one. Right. So now I'll come to the very important question. That is question number 9, which I use in proving question number 11. This is very, very important, and you should remember this as the important property for doing the problems. Right. So I'm doing this. Just you observe. If you will be having any question, you can ask me. I'll start with the left hand side. So without much delay, I am doing left hand side is A union A intersection B. And I have to show that this is equal to A. How do we proceed, you see? I'm going to do something here which is very, very important. See, the single A which is there, I'm going to replace it by something. But I have to replace it in such a way that this whole is equal to A, number one. Number two, I should use also intersection operation, right? So that I get A. So what I can write is here, right here is A intersection U, universal set. Now just you remember A intersection U will be giving U. A only, right? Venn diagram only says Venn diagram. Right? Now for a reference, quickly, I would like to just tell you this also. Suppose this is U, suppose this is U, and this is A. This is A. Right? Suppose this is U, as I told you, and this is A. Now, from the figure only you try to see intersection of this with this. Which part will be there? A is only there, right? Because common of A with U is A itself, right? So write, I can write instead of U, sorry, instead of A intersection U. Now apply the distributivity in the opposite direction. So what I'll get is here is A intersection U union B, right? Distributive property in the opposite converse direction. Fine. Now, what do you say from here? U union B. Now, if you mix a set with the universal set, you will get only the universal set, right? Because universal set is the bigger set in that discussion, biggest in fact. So now from here, what will say? Again, you'll be getting this. That is equal to RHS. That is equal to RHS. So you are done with this. You are done with this, right? So you go through it once, and once you have, please raise your hands so that I can understand that you have finished it. Okay, now I'll be doing the right hand side, sorry, the other also where it is intersection. Now here what we do, your trick it is. Earlier inside the bracket, the operations were it was intersection, but this time it is union. So here I have to bring union and you have to keep A alive. So now union of A with whom will still result A? Fine. Very nice. So now again distributive property will give you what? A union phi intersection B. Now anything or any set taken intersection with empty set will be always giving you phi only. So this gives you A RHS. That means you got the proof. First proof is what? A union A intersection B is equal to A, and second one is A equal to A union. I wrote the no, I wrote it correct. Okay. This is intersection A union B. So these are the two proofs. Please note it down and intimate me. Okay, thank you so much. So now I'll be doing question number 8. 8 only one part I'll do, and that can be finished here only. The second part will be your task. They are asking you to prove these results by using the properties of sets. Nothing is told, so you can use properties of sets. So as the bigger part is in the right hand side, better to start with the right hand side. It is A intersection B union A minus B. Now if you try to remember the property of sets, what you can write here it as A intersection B complement. Just try to remember, right? You can go back to your copies. We have already done this. So here also we are going to apply the distributive property in the reverse direction. Then I'll be getting this as B union B complement. So B union B complement together makes what? Complete universal set. And with universal set, if you take the intersection, it will be A only. That is equal to LHS. So henceforth. And in the similar way, for question number 8 also you can proceed, but that I'll not do. That will be your task. Right? Once you finish, I'll go back, go to the next one. Okay. So I'll be going for the next question. That is question number 7. Again, see, these are all important questions, so I'm not giving chance to you to do. There will be some problems I'll be taking to you for doing. Question number 7. Is it true that for any sets A and B, if PA union PB equal to P of A union B, means for any two sets, is it true that power set of A union power set of B is equal to power set of A union B? Is it true? So normally what happens, if it is true, it is asked to be to prove, right? But whenever there is doubt that it may not be true, question only indicates you that it may not be true. So when somebody asks you, is it check if, that means there may be something wrong with the equation. So here also as they are asking to check, it means that this may not be correct. So whenever it is not correct or it may not be correct, it is very easy to prove. Just you have to identify one counter example, right? You need not prove it in a general way. It is enough if you look for one counter example. So here also we'll try to consider counter examples, and then with the help of that, we'll see whether this is true or not. So for finding the counter example, we want to take small sets, right? Do not take bigger sets as a counter example. Otherwise, it will be too big and you will not be able to identify. So we will consider these two sets, right? So clearly, see, you will have to now visualize, because I'm not going to write PA, I'm not going to write PB, neither I'm going to write P of A union B. But of course, I'll write what is A union B. So A union B will contain all these four elements. Now, power set of A, please try to recall, power set of A, that is P of A, means what it was? Set of all subsets of A, set of all subsets of A. So now let us try to find one such a subset which may be here but you will not find here, or it may be here which you will not find here. That will disprove the equality, right? So we can easily find. We can easily find. Let us just try to observe. You can see clearly. If I talk about the power set of this, then I can get a subset containing 2, 3, and 4, 3 elements. This is obviously a subset of A union B, right? Which implies that 2, 3, 4 is belonging to power set of A union B. But can you say that 2, 3, 4 is a subset of A, or can you say that it is a subset of B? Can you say? No. So we'll write, but this is not a subset of this. Now and will come here, and this is also not a subset of this. Why? Because in both the cases you can find some other elements. Like for being a subset of A, I should have got 1 or 2, but here you see 3 and 4 are unwanted. For being a subset of B, I should have got 3 and 4, but I got 2 extra. That means this is not a subset of A as well as B, which in turn imply us that it is not belonging to PA union PB, right? Am I clear to you? So if it is not belonging to this, so very clearly you can say that P of A union P of B cannot be equal to P of A union B. Now, which one is subset of whom, that we will decide. Now, in fact, you can say that this particular part is a subset of P of A union B, right? P of A, right? I'll write that only. In fact, P of A union P of B is a subset of P of A union B. It will be like this, not equal, right? So please note it down. And one homework for this I am saying, just try to prove this. It will be proved, right? If I am talking about intersection, then you can prove this. For intersection, it is true. For union, it is not true. So you will prove this and you will show me. If you finished, then you please inform. Okay. So I'll go to one more question. That is question number 6. That is again very important question. So that proof also I'll be doing. Question number 6 proof I'll be doing. So that, sorry, assuming PA equal to PB, you have to show that PA equal to B. So I directly start with the answer only. We have PA equal to PB. Okay, now just you try to see. We did not mention earlier. If I say that A set is equal to B, what does it mean? A is a subset of B, and at the same time, B is a subset of B. Right? That means if somebody asks you, so that A equal to B, it is to be shown that A is a subset of B and B is a subset of A. Meaning, every element of A should be also found in B, and every element of B should also be found in A. So this is what you have to prove in order to say A equal to B. So now we'll be starting with that idea only. Let me start with the element in A. If this is an element, then I can construct a singleton set taking X as the element. So obviously this will be subset of A. If any subset I consider for a given set, it will be always a element of the corresponding power set. There is nothing wrong to write it. Now, as PA equal to PB, I can write it here. Okay. If X, this singleton set X is X is in power set of B, it means invariably that it is a subset of B. Now this implies that X must be element of B. So what did you offer? What did you identify at last? That X belongs to A you have started with, and you finish with X belongs to B. X belongs to B. Now you see I'm going to write something which is not to be written. Till here you write here. Till here you write. Till here you write. Okay. So if you write here, you see what I'll get from here. You need not write now presently what I'm going to write. You just see it. From here, I can get this result. What result I can get? Because every element of A is also in B, my conclusion is what? A is a subset of B. So for the other part, I'll take one element in B, and with this calculation, I have to show that it is also in A, right? But here, luckily, if you observe again little carefully, the whole steps is going backward this side. You can see if you start with element X belongs to A, B, then this is true. That means this will imply this further step. This will imply the next. 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 So actually, this part is not to be done separately. If you do it, you can do it. It will not be wrong, but you have a scope to apply both the arrowheads, like implies and implied by. So what will happen? I can write it here also. So in the opposite direction, what will it imply? B is a subset of A, right? So you only write this part, what I have filled up here. This part only you write. These parts you write. Do not write these extra parts. So I come up to this bidirected arrowheads means A is a subset of B and B is a subset of A. So what my conclusion will be? A equal to B. So this is the way how we prove these results. PA equal to PB implies A equal to B. Okay, let's see that, and once you finish with, indicate me. Okay, so now I'll be going for one more question, that is question number 5. Question number 5 will be there. Number 5. Question number 5 is also important. It is an important question. What they have asked you to do, if A is a proper subset of B, then that implies C minus B is a proper subset of C minus A. This is to be proved. Okay, now at the beginning, forget about the proper subsets presently. Think only about subsets. After that, next step we'll think about proper subsets. So if I have to show that this is a subset of this is a subset of this, means this is a smaller set than this, and this will be inside this set. That means whatever element I consider from this set, I should get also it here. Once I will be able to show that, I can say that this is a subset of this. But to show that it is a proper subset, I should convince that this will contain some more elements than this. So this is a two steps problem. First we'll show it as a subset, and then we'll show that the right side set will contain more elements than the left side, which will show that it is a proper subset. So two way. Now we'll be starting with. See, This implies this part means this is to be given, right? This is the condition which is given. So we'll start with that. Given that A is a subset of B. Now I'll start with a random element from the set C minus B. This implies from the definition that X is in C, but X does not belong to B. X does not belong to B. Very good. If X is in C, let it be in C only. Now, can I write from here that X does not belong to A? Yes, I can write since A is a proper subset of B, right? ध्यान से देखना है. A is a proper subset of B means B contains some elements which are not in A. Otherwise, every element of A is a part of B. So now this tells you that there is one X which is not in B only. There is one X which is not in B only, right? So how can it be in A? Not possible because A is a part of B. So जब element B में ही नहीं है, so it cannot be in A. So I can write from here that this implies X does not belong to B implies X does not belong to A, right? Because it is the smaller set and part of B. So now once this happens, I can see that this is belonging to C minus A. So overall you observe, you started with one element X belonging to C minus B and ultimately you finish with that element belonging to C minus A. So, and this happens for all X, remember it, this happens for all such X. So according to definition of subsets, I can say now that C minus B is a subset of A. C minus B is a subset of A. I don't know now till that they are proper or not. Now that is the second step we have to verify. Till here you write and indicate me that you have finished it once you do it. And if you have any question, you can raise it. Okay. So now the next part we can do here. Also, A proper subset of B implies, just now you have to think, A proper subset of B implies, what will it imply? A is not equal to B, right? Proper subset if it is, had it been subset, we could have got one option that if I would have got this, so I could have got one option. Maybe it is equal or A subset of B. But once I get A subset, proper subset of B, then there is no question that equality holds. So it is very clear. And now if equality doesn't hold, you can easily justify that these two sets cannot be equal. Because C is the fixed set here. So from here you have taken the differences of the sets A and B. So as these and these are not equal, so difference cannot be equal. Right? So what did you understand? This is a subset of this, but this is not equal to this. So together with these two conditions, if I try to imply what I should get, C minus B is a proper subset of C minus A. Hence the result. Hence the result. This is the result. This is the result. I am finishing this exercise here only. I'll be doing now some extra problems and then I'll be winding up the chapter. And the problems whatever are left out in the book, it will be your responsibility to go through it. If any problem you find, you will intimate me. Okay, so I'll go for a very important question now. This is not in the book. It's a separate question we are going to do. Question one I'm writing because this is separate question. Number of subsets of a set A is 56 more than the number of subsets of another set B. Then find the number of elements in of the sets. So this is the question which we have to do. If the number of subsets of a set A is 56 more than the number of subsets of another set B, then find the number of elements in each of the sets. Please note down the question and then let me know. I'll go to answer it. Okay, thank you. So now I'll start. See, okay, I don't know absolutely how many elements are there for set A and for set B. So we'll start considering. Say number of elements in the set A be M and number of elements in the set B L. Fine. And obviously, from this particular data, you can see that A has more number of subsets. So obviously, number of elements in A must be more than number of elements in B. It is very, very clear from the given data, right? So this also is indicative. Now, according to question, how many subsets are there for n of A? It will be 2 to the power m. How many subsets for B? 2 to the power L. And what is the difference? 56. Fine. Now, if you can solve this particular equation, then you are done. Right? Now you see one thing very, very clearly. Out of this M and N, M is bigger. M is bigger. So I can take the lesser power common. I can take the lesser power common that you can easily identify. So I am going to take 2 to the power L common. Then I'll be getting this as 2 to the power M minus L and then 1 here equal to 56. Now actually we are doing this so that we can easily visualize the problem and we can put it in the proper pattern. So now we'll try to put the right hand side in this particular pattern. So for that, right hand side must be factorized. You do the factorization and see what you will get. We'll be getting something like this. That is 56 is equal to 2 cube into 7. Right? This is
Sir,
actually, yes,
there was some network issue. I could not hear the answers. Can you please start again?
completely you did not hear.
Sir, I heard till 2 to the power m minus 2 to the power l is equal to 56.
Okay, fine. I'm repeating this. I'm repeating this. So
Thank you, sir.
you got here 2 to the power m minus 2 to the power l equal to 56. But from here you can see that m is bigger than l. That means this number is bigger than this number. That means this power is bigger than this power. So the smaller one I can take out as a common factor. Then here what will be left out? 2 to the power m minus l will be left out. And this whole as I have taken common, 1 will be left out. And right hand side is 56. Now what I'll do, this 56 I'll try to put it in this form and I'll do the comparison to find m and n. So to put it in this form, we have done the factorization of 56, which is coming out as 2 to the power 3 into 7. So this I am going to write now, right? So this will be equal to 2 cube into 7. Now anyone can visualize, anyone, right? It's not that any special idea is needed for visualizing this. That if this is power of 2, it must be compared with this only, right? And this part will be comparable with 7. No one should compare, if of course he is normal, this 2 to the power L with 7. It will not be compared, right? So this is going to indicate us what? 2 to the power L is equal to 2 to the power 3, and 2 to the power m minus L minus 1 will be equal to 7. Now from here you can get L equal to 3, and here now you can go on putting the values. 2 to the power m minus L is equal to 8. 8 means 2 to the power 3. So what you will get? M minus L equal to 3, giving you value of m as 6, because L is equal to 3. So ultimately you have found out what is the value. M is equal to 6, n is equal to 3. That means number of elements in the first set is 6 and number of elements in the second set is 3. So that is the very important question. It came actually in Z mains. I don't know the year. This came in Z mains, right? So this is a question, very important question. Please see that, and once you finish, let me know. Okay, thank you. Now you try to see this same question. Same question you have to do as a homework. Same question. Only thing is that this 56 will be considered by you as 48. Question remains the same, completely same. Only 56 is replaced by 48. And then you will do it. Now I'm going for the next question. Now question number 2. I'm going to do question number 2. Question number 2. Please write the question, because this is different question and important question. It is going to be an important question. A survey shows that a survey shows that 63% 63% of the people watch a news channel, whereas 76% watch another news channel. News channel. Another news channel. If X% of the people watch both the channel, then right, then there will be options. There are options. I am just writing like this. Then find the range of X. That means between which to which number, or between which to which percentage this X will lie. Please note down the question. Once you finish with the question, you tell me. I'm going to do the problem. Okay, this is again a question which is of importance. This again, I tell you that this came in Z. Which year that I don't know, but it came. So now they have told you that there are two channel, 63% watch one and 76% watch the another. And X percentage like both the channels. Now you have to tell X is lying between which particular number to which particular number, right? So here as everything is given in percentage, universal set contains everything which is equal to 100%. So anyway, for making the question formalized, I am writing it like this. Suppose A is the first channel. It is the first channel and B is the second channel and number of person liking A is suppose 63. I am not writing percentage because if I consider the totality to be 100, it will be 63 and this is 76. And liking both or watching both the channel is X, right? This is the case. Now we have to find in which particular range this common number of persons belong, right? So here you see, we are going to use, when I explain the set theory, I think I use some restrictions on the limitations on number of elements of A union B, A intersection B, etc. So here what I can see. First of all, do one thing. You find what is A union B. You find first. Let us find this. Because A union B is going to give some relation where X will be involved. So let us first find this. So this is 63, this is 76, this is X. Together this is going to give me 63. It is 9, 139, 139, right? So this is 139 minus X. This is the number of elements in A union B. Fine. Clearly, right? Clearly, I have one very important relation. We have to only identify this important relation. What is the important relation between this n of A, sorry, n of U and n of A union B? See, this is the set which represents the persons who likes or who watch at least channel A or channel B. But universal set is the set containing all the people. So in all that people said, there may be some persons who doesn't like any one of the channel. So in other words, I can say like this that number of elements in U is greater than or equal to n of A union B. Maybe equal, if not equal, then always this will contain more number of elements. And what is the number of elements here? If I consider 100 percentage, so it will be 100, and this is how much I got, 139 minus X. Now if I try to solve this inequality, what am I going to get? X will be greater than or equal to 39. So one of the part I got, X will be greater than or equal to 39. This is one. Again, common part is always less than or equal to the individual sets. This I have written. If you go back to your notes, somewhere I have written this. So very clearly you can say that X is less than or equal to 63, and this will tell you X is less than or equal to 76. But remember one thing, be very alert. These two conditions are to be satisfied together. That means here and here and. Now, if you draw quickly a number line, just to explain you, I am drawing this. If you draw quickly a number line and you try to identify x less than or equal to 63. So first let me put the number. This is suppose 63 and 76 will be somewhere here. X less than 63 means this side, right? Less than or equal to 63 means including 63 left side. And X less than or equal to 76 means what? This side, which is less than 76, including 76. Now, if somebody tells you that both these results would be true at a time, so which is the part where it will be true? This will be this part. This side both will be true. See, both the marks are there. That means together this is going to imply x is less than or equal to 63. This is the another condition. Now this is one here. This is the another condition. This is the another condition. Now 1 and 2. Swanav, you can hear me? There is a disturbance in network. You can hear me?
Yes, sir.
Okay. So now 1 and 2 will imply 1 and 2 will imply what? X is less than 63 and greater than 39. That means X is lying between 39% to 63%. So this is the answer here. This is a very important question. Very, very important question. Please mark it as very, very important question. Right? And today I'll finish little early. Once you finish it, please tell me. I'll finish it. We'll see you in the next day. With the new chapter, relation and function will start. So by the time you will finish all the questions of the exercise. Okay, Swarnav, so bye for today and we'll see you on the next day.